Hi, in this video I'm going to be talking about spheres, and specifically I'm going to be talking about surface area and volume. We're going to start off, this is going to be a two video series, a couple of videos put together. The first video is just going to go through some basic information like the formulas and some basic stuff. The second video is going to be a little bit more problem solving and a little bit more abstract stuff, a little bit more difficult stuff. First things first, let's talk about the area, or the formula, excuse me, for the surface area of a sphere. The surface area of a sphere, pretty simple. It can be found by using the formula 4 pi r squared. Now, I'm not going to explain how they got this. It actually involves a little bit of calculus if you really want to understand surface area and volume of a sphere. But if you go look up Archimedes, that would be Archimedes, okay? If you go look up him and how he found the surface area and volume of the sphere, it's actually a pretty cool little backstory and a pretty cool explanation for how it happens. And I might do that in class, but I'm not going to do that in this video. Really what we want to do is just be able to utilize this formula. So the radius of the sphere, typically you'll see the sphere drawn like this and the radius will be designated. So whatever this might be, let's say that this is 3 units. Okay, let's just make up a number. Let's find the surface area, the external surface that is exposed to air of this 3-dimensional sphere shape. It's going to be pretty simple. The surface area would be 4 pi times 3 squared, right? 3 squared is 9. Order of operations says that I want to do that, so that's going to be the first thing I do. So it's 4 pi times the square of 3, which is 9. And now I can combine the 4 and the 9 pretty easily. I see that I have 36 pi. I should have put in the units in here. Let's say that's centimeters, so we have something to work with. That'd be square centimeters. And area is in square centimeters, right? If I wanted to go ahead and multiply that out, 36 times pi gives me about 113.1, approximately 113.1 square centimeters. Okay, either way, depends on what you're looking for. You're looking for how many things in terms of pi, or are we looking for approximate answers? Let's do one that's a little bit more algebra based. Okay, this is typically what we see on our end of course exams. Let's say that the radius is, let's say 2x units in length. All right, what's the surface area of this thing now? We know the formula here. It is 4 pi r squared. So we're going to do 4 pi times 2x squared. And what I want you to notice as I start to go through this is that the 2 is part of the radius, but so is the x. So they're both going to get squared here in a second. The 2 and the x both get squared. I have 4 pi, 2x times 2x, which is what that thing means right there. That means 2x squared, written like that, means 2x times another 2x is 4x squared. So like I said, the 2 and the x both get squared. All right? Now it's time to combine all this stuff. 4 times 4 combines pretty easily. That's 16. I have a pi that I'm going to multiply by, and eventually I need to multiply by x squared. And I don't know what my units are, so just square units, whatever the heck I give you there, right? But the surface area of that shape would be 16 pi x squared. That's a good algebra problem. That requires, you can't do that on the calculator, in other words. So that might be what we see on like our end of course exams later on. All right. Let's go through now. So I hope you have that written down, or I hope that have that memorized somewhere. Put that in your back pocket. Put it on a flashcard. I don't care what you do. You got to figure out a way to memorize that formula because the surface area is a different formula than the volume of a sphere. So let's go through and let's do the exact same spheres. Okay, here's a sphere with 3 centimeters. Here's a sphere with a radius of 2x. Let's go through and find the volume of these two shapes. How much 3-dimensional space do they take up? The formula for volume is 4/3 pi r cubed. R cubed, cubic units, just like we expect to show up with volume, as opposed to surface area where we expect square units to show up, right? So remember that. That's one of the big things that catches people is they have trouble remembering, is it r squared or r cubed? Volume gives us cubic units. We use the cubed r. Same idea here. We just want to go through and be able to manipulate the formula to follow order of operations in order to solve for the volume of the shape. This one is going to be 4/3 pi times 3 cubed. I'm going to do the cube first. So I have 4/3 pi times, and 3 to the 3rd power is 27. Now I need to take 4/3 times the 27 and combine those. 27 divided by 3 is 9, and 9 times 4 is 36. You can always use a calculator to figure that out. but it turns out the area is the volume is 36 pi, and now we're talking cubic centimeters instead of square centimeters. If I go through and I multiply 36 by pi, once again, 113.1 cubic centimeters. So it just so happened that I picked a number, oddly enough, where the surface area and the volume were the same. That is a coincidence. That is not the normal thing for you to see. Okay, I want you to understand that is a coincidence, totally. Let's do the same thing here. This time I'm going to take 4/3 pi times the 2x cubed. Okay, this statement right here, the 2x being cubed, means that I'm going to multiply. You know, in fact, let's use a different colored pen. This part right here that I'm looking at means I have 2x times 2x times 2x. That's what it means to have the 2x being cubed. The 2 and the x are both part of the radius. So I combine numbers-wise. I have 4/3 pi. I'm going to leave that out, okay? But the 2x cubed turns into 2 times 2, which is 4, times another 2, which is 8. And then I have x times x times x, which is x cubed. All right, this one's not going to be nice and neat whenever we get done, but it's all right. The formula looks like if I took 4/3 times 8, and I typed into my calculator and I get a fraction, 8 times 4 is 32, divided by 3 is not a nice number, so I'm just going to leave it as 32 thirds. And then I have a pi, and I have an x cubed. So there's the volume. Now you see that the volume and the surface area aren't always the same, right? Another way I could write that, if you like it this way instead, 32 pi x cubed all over 3. That would be an acceptable way. That's the same exact thing. At some point in time, I'm taking x cubed, I'm multiplying it by pi, I'm multiplying by 32, and I'm dividing by 3. All right, hopefully that makes sense. The next video is going to be about hemispheres. We're going to get into half spheres and talk about how our formulas change, because it's not the same formula. And so you'll get to see that, and you'll get to see me manipulate and do some tougher problems.